Hi everybody, we're going to move on to dividing monomials today. This is something we did talk about last year, so this is review again, but let's go through this and not necessarily say what the rule is, but say why the rule is what it is. So we're going to start the first problem here. I want to take 4 to the 5th power and I want to divide it by 4 to the 3rd power. Now, when I have exponents, that means I have repeated multiplication of the same base. So in this particular problem, we have 4 times 4 times 4 times 4 times 4 for 4 to the 5th power over 4 times 4 times 4 because we're dividing by 4 to the 3rd power. Now, since I have multiplication here and the opposite is division, I should be able to divide out anything that's the same. Just like when we were little and we learned when you divide something by itself, you get 1. So for instance here's a 4 and here's a 4. I can divide them out. They both turn into 1. I can go with these 4s and these 4s. They all divide out to 1. So what's left here? I have 4 to the 2nd power left. And I could put it over 1 because the denominator 1 times 1 times 1 is just 1. But I'm not going to put it over 1 because that'd be the same thing as making, if I want to make a whole number a fraction, there's no reason to do that. So 4 to the 2nd power is 16. And that is the final answer to this problem. So looking back at the original problem, what did I really do here? You can see what I did with the exponents. It turned into 4 to the 2nd power. You can see I just basically subtracted them. But you have to be careful here because where were the 4s that were left over whenever I went through and did my work? They were left in the numerator. You can notice that the bigger exponent is in the numerator of the original problem. So be careful here so you know where the leftover 4s are because that determines what the final answer is. And we're going to get into negative exponents next week, so keep that in mind, but I want to see why does the rule work. And you can see why it works here because of when I divide something by itself, I get 1, and then whatever's left, I go through and do my problem. All right, let's take a look at another one. Example 2. Now I'm going to throw some coefficients in here that are not 1. So in this particular problem, 4a cubed b squared is over 6a to the 5th b. So looking at these coefficients, first of all, if I had the fraction 4/6, I could simplify that very easily. The greatest common factor of 4 and 6 is 2. So if I take 4 divided by 2, I get 2. If I take 6 divided by 2, I get 3. I still need to simplify my coefficients if possible. Now, expanding my numerator. A times A times A times, I have B times B. In the denominator, A times A times A times A times A, there's 5 of them, then times B. All right, so multiplication again, the opposite's division. So if I can divide something by itself, it'll automatically turn into 1. So those turn into 1. Dividing A by itself there, A by itself there. Now I don't have any more A's in the numerator that I can cancel out with these down here to divide out to 1, but I do have some B's here. I can take these 2 B's and divide B times B, or B divided by B, and get 1 again. So going back, what's left here? Okay, don't lose your coefficients here. I still have my 2/3. In my numerator, I am left with a B. So 2 times B, 2B. In my denominator, I'm left with 2 A's that are being multiplied together, so A to the 2nd power. So I'm getting 2B over 3A squared. So let's take a look at this again. Looking at my exponents here. For my A's, I had a 3 and I had a 5. Now, yes, we are subtracting. And like I said, we're going to talk about negative exponents next week. But why are my leftover A's in the denominator? Because when I expanded this, the A's that were not divided out to 1 were left in the denominator. And as for the B's, the B that was left over is in the numerator. And we know the exponent on this B right here is a 1, so I can think of this one as 2 minus 1, just give me this B in the numerator. If I do 3 minus 5, I get -2. And like I said, we'll talk about that next week. But as you can see why the A's are in the denominator, because that's where the leftover A's are in the problem. Okay, we're going to do one more example. That's going to put our multiplication practice from yesterday together along with our division today. So you can see I have all of this being taken to the power of 2. But I want us to think back to the order of operations. If I can simplify anything inside the parentheses first, that's going to make it easier whenever I go through and try to figure out my final answer. So let's think about this for a second. First of all, with my coefficients 2 and 3, they're not going to simplify anymore. So I'm going to leave that 2/3. Now let's think about this. I have x times x over x. So how many x's are left and where are they? There's one x left and it would be in the numerator. My y's, I have y divided by y times y. So where's my leftover y? In the denominator. Now this is still in the parentheses. Like I said, we did the order of operations here and it kind of simplified our problem more than if we were to jump straight to the exponent. But now everything's left inside the parentheses. There's nothing else I can do with it. So I have to square everything, including the coefficients. So be careful about that. So when I square my 2, it says I need 2 sets of 2. So 2 sets of 2 is 2 to the second power. 2 sets of x would be x to the second power. Now the denominator is also getting squared. So 2 sets of 3 and 2 sets of y gives me that. Now the only thing I can simplify more here are my coefficients. So 2 to the second power is 4. My x squared over 3 to the second power is 9. And I am left with my y squared. And I can't do anything else with my variables there. So 4x squared over 9y squared is my final answer. Now I would have got that answer even if I would have squared everything from the beginning of the problem, but again, I would have caused myself to have more work. Also, that would have given me more opportunities to make a silly mistake. So just be careful whenever you're doing these types of problems. If you have any questions, get back to me. You know how to get in contact with me. Again, I really wish we were in the classroom. This would be something that we could talk about a whole bunch more and you guys could answer my questions rather than me basically telling you what to do. So have a great day, guys. Talk to you later. Bye.